Hi everyone. So in this video, we will be going through the Honeybee-Radiance tools that are kind of part of the the Ladybug suite of tools that you can get for Grasshopper. Um, Specifically, I'll be going through the annual daylighting study, which is a very kind of basic study that you can do to analyze the daylighting on the interior of a space, which can then be used to inform, how you might lay out the interior, or how you might orient the space, or the how you might shade it, or with the exterior and things like that. Um, this is really meant to be a very introductory kind of tutorial. I'm not going to be going too deep into any particular topics. Um, I myself am not an expert energy modeler by any means. I've used Honeybee a tiny bit in the past, and there was, as of the time of this recording, they released a new version just a month or two ago, um, and they're going to be continuing to add some of the tools to it. But I kind of wanted to. I was having a hard time finding more recent tutorials online as I was trying to do an example for the class myself. So I figured I'd record this and put one out there for anyone who's just looking to get up and running with Honeybee on the newer version of the tools. Um, so with that said, I'll kind of jump right in. Honeybee, for those of you who don't know, is it gets a little bit more into the zoning of spaces, and there's a number of kind of ways in which directions in which you can apply it, whether it's an energy model or it ties into radians. So you'll have to, when you do the install of Honeybee and Ladybug, you would also need to install radians in order for a lot of these tools to work. And so, like when you install it, there's actually kind of three different Honeybee tabs. So the generic one is kind of like where you set up a lot of the general tools to set up the model and the zoning and the shading and the apertures and things like that. The radiance ones are the ones that are dealing specifically with lighting, and then the energy model ones deal specifically with kind of HVAC and energy and schedules and things like that. So I have, just for the sake of speed, I've kind of baked in a couple things into the canvas here. So I have just a very kind of generic context, like urban sort of context, and then I have this model, which would, hypothetically, this could be maybe a floor on a larger, building or something like that if you have something. So it's you want to run this early on when you're still kind of like figuring out your overall massings and things like that usually. Um, so usually when you're running this, you have very kind of dumbed down geometry that you're using, and because this is doing a lighting analysis, you don't want anything too geometrically complex at first, especially, or else it's going to slow things down. So with that said, so typically, when we're working in Grasshopper in general with visual programming, you're often kind of working a little bit backwards. So that's what I'm gonna do that to start with. So like I said, we're gonna be looking at this Honeybee annual daylight tool, um, and we'll kind of just rough out the workflow as we're going, and the way in which, because the tools within the Ladybug Honeybee suite of tools are all really, really well documented in terms of when you hover over these things, they tell you what they are expecting and what's required. So in this case, the main thing that we need is a model. So there's a Honeybee model that we'll need to build. So that'll be, kind of the step prior to that. So this is kind of like where we're setting up like the analysis, which gives us a recipe that will run. Then we kind of need to develop a model. So the model is going to be made up of our rooms and other things like shades and things like that, apertures. And so the kind of step before this will be to generate the rooms. So if we go to HB room, this will kind of create a Honeybee room. Um, and so we'll actually what I want to do, actually I'm going to get the room from solid because I already have a piece of geometry that I'm going to stick into this input here. So my room geometry, I've set up a couple things here just to save some time. So I have the shading here, which is just right now it's just kind of like this dumb little overhanging thing. And then I have my glazing would be my apertures here. So this is kind of just like a very basic setup, and I'll talk a little bit about if you wanted to customize the analysis off surface as we go. So as far as right now what we have, there's going to be kind of four main groupings of steps. One will be kind of setting up the rooms and the model and everything. Next will be like setting up the model and the grids and making and getting our overall kind of like mesh to run the analysis. Then setting up running the analysis itself and setting that up and then visualizing it. So those are kind of, if we think about the four main groups of how this would break down, that's roughly what we're going to be doing. All right, so first we'll be kind of just generating the room. So this is kind of usually your first step would be to generate the room, and if we wanted to, we can name it. So or something like that. I don't know, whatever. Name it whatever you want. You can also, in this example, I'm only going to be doing one room for the sake of speed, but you can feed it like a list of rooms. If you do that, you'll just have to be a little bit more mindful of your kind of data management as you're going in terms of like the apertures and what apertures belong to which room and things like that. So for the sake of simplicity and speed, I'm just doing this on one room, but you can kind of feed in a list of rooms if that's the preferred approach. So and so you can do things like set up the roof angle and whatnot here. So I'm just going to leave these for now. Like I said, I'm going to be, this is really meant to help people get started, and then from there they can kind of customize, as needed. But I think just getting started is often really the hardest part with a lot of these tools, and then because they're so well documented, it is easy. Well, I shouldn't say easy, but it's feasible to, if you have the will to do it, to, really begin to understand what's happening and begin to tweak it to match exactly what you want. And so we can add shades. So there's like the shade, HB shade. So this is if we had our own kind of shade, which is like our little overhang here. We can add that here. And if we wanted to, we can, name it and whatnot. There's also this, is it attached? So this is automatically set to true if the shade is assigned to a parent room face or aperture. So there's kind of this schema of as you're going that's really important to understand with Honeybee, and it's really well documented on their website. So I've pulled this up here just to kind of show you. I'm not going to go through it in depth, but I definitely, if you're doing a Honeybee model, definitely before you start, take a look at this and kind of go through and begin to just understand how things are organized, and they have some clear diagrams as to how that is done. So you can see here, for example, like typically if you have a shade that's specific to a room, the parent object of that would be the room. It could also be, you can also apply shades to apertures or doors or faces. And then you kind of have above, if you were to go one step above the room essentially in a way, you would have kind of your model. And your model can have all these sort of like orphaned things which like don't necessarily belong to a room. So you can have shades and things. So you can read through this to find out more. So in this case, like from my understanding, is like if you have like urban context, for example, that would be something that shades the space that doesn't belong to a room. So that would be an example of kind of like an orphaned shade, for example, in that case. And you can kind of go through and read the different schemas, and it goes a little bit more in depth for apertures and shades and rooms and whatnot. So definitely check that out. But I'm not going to go through that entirely right now. So with this, we have a shade. We can do the add shade, I believe, HB add shade. And so now we have our room would be the object, and then there's kind of like shades that are going to be on the outside of the room or the inside. So in this case, our shade's going to be on the outside. And then we can also set up another way you can do shades, which I think is just kind of a cool thing worth mentioning, is like there's some built-in tools for creating like louver shades. So if you wanted to, we can have, well, before we would need to do, we can add to an aperture, we can add shades. So we saw that in the diagram before. So that's one of the options, that shades can belong to an aperture. So we're going to set up the glazing as our aperture. So these are kind of just the window geometry. And you know, I can name it and make it clear, but for the sake of speed, I'm just going to keep going. So the apertures will come into our object here for the louver shades, and then we can set like a depth to the shade. So I might make it, you know, a foot deep or something. And then you can supply either a shade count or, you know, distance between shades. So if I wanted to say, you know, I think you have to do either one or the other, not both. So if I wanted my shades, maybe I'll make it a little bit more spaced. I'm in feet right now, just in case you're following along. If you're in meters, you might want to just adjust accordingly. Or, whoops, I meant to do distance between. And then you can kind of set if I wanted the shades to be, say, I wanted these to be kind of like these vertical fins or something, I can do that as well. So you can set up shades, and this is also something that like you might run the analysis first and then decide, oh, you know, this is a part of the building where I might want to add shades. Let me go back and add some shades there and see, you know, what makes sense for shading that. So this is like something you might do almost retroactively after you first run the model, but as I figured I'd just mention it now as I'm going, as something that you can do. And then in order to add kind of all this stuff to the room, there's this add subsurface, I believe, add subsurface or subface. Yeah, subface. So our rooms are going to be the objects that are coming in here, and then the subfaces in this case would be our apertures. So if we kind of just look at what's coming out of here, this is still, you know, the object that we're getting out is still the aperture, because the shades belong to the aperture and the parent object is the aperture. So this is our subfaces here. And another thing we could also do, which like you would typically, I think it's a good idea to do, is there is kind of, you can add, let's see, I forget what it's called. There's like to add the depth of the, I think it's like border shade or something like that. Here, extruded border shades. Here it is. It's in the generic kind of Honeybee tab there. So we can add shade, like this is to add depth. So, you know, most of our exteriors of the building are going to have depth. So if this is a room that's against the exterior of the building, we might want to do that. You know, so I might make this a foot or so. And then you can choose like whether it offsets inside or outside by setting this toggle as well, I think. So I'm just going to leave that for now. Alright, so that's basically the first step, which is kind of the most important and the harder part for this exercise. So we have our rooms set up now. And so now we can plug this stuff into the model. So the HBS objects here, this is going to be our rooms. And that'll go here. And then the other thing I wanted to add here was the context. So this is my building context here. And I'm just going to copy and paste this Honeybee shade component and create the context. And so I'll add that to the shades. And if I wanted to, just to make it clear, of course, I can, name it. Again, this is more useful if you have like a lists of different shades and rooms and things. For the purpose of this demonstration, the names are kind of not really necessary, but anyway. All right, so the next thing we're going to need for the model is you also need to kind of create a grid for where the points go. So there's a couple ways we can do this. There is grid rooms, I believe. HB sensor grid from rooms. This is kind of the quick way to do it. If you just wanted to have the grid be kind of the entire room. So this is the grid, like the grid of basically be the mesh that is going to get analyzed. So for the sake of speed, I'm going to keep the grid size pretty big, but if you're running this, you might want to make it smaller just to get a little bit more of a fine tune. And then let's say this is like an office space. I might want to actually offset this like a desk height or something like that. That might be a more like relevant surface. So I'm going to offset from my floor. I'm going to offset 3 feet. The other way we can do a grid is, so that's back to here. If you have like a specific portion that you're interested in analyze, like maybe you have some room, but you don't really care to analyze the entire room. Maybe you just want to analyze a portion of the room. You can do that, and then you can kind of set it up so that you can do like generate. There's the Ladybug generate point grid tool, and you can generate a kind of grid off of that. And it has some similar inputs for like the grid size and the offset and whatnot. And then you can create a sensor grid, HB sensor grid. So the mesh would come here. The vectors would be your directions. The points would be your positions. You can name it if you want. But this is basically kind of the same, a similar thing of what the grid rooms tool is doing. So if you wanted to kind of customize the area that was getting analyzed a little bit more, you can do it that way too. But I'm just going to leave it with the grid rooms approach for now. And then, so we have like our model and the grid, and then we kind of just need to combine the two. So you can do that by assigning the grid to, what is it? Assign grids and views. So this is the model. These are our grids. We don't have views in this case. One thing we might want to also, that's helpful to do, is the visualize wireframe, HB visualize wireframe. So if you want to visualize kind of the model that we have, and maybe at this point I'll hide all of our reference context. And so now we can see, the nice thing about this is it shows us like the louvers that were generated that we didn't necessarily model. So we can kind of just make sure that these look, like a reasonable size and whatnot. So this is just a good kind of verification to make sure you have everything that you want. All right, so now so this is kind of the, what do we say, the second step, I believe, where you are setting up your model and your grids. The third step now is just to kind of run the analysis. So this will come into here. Now, to save some time, I've already pulled in the weather data. So we've done this kind of with some of the Ladybug tutorials in the past, so I'm going to gloss over this pretty quickly, but you can get the EPW file. You can use the Honeybee EPW map website, Ladybug the ladybug.tools /EPW map and kind of zoom in to wherever you're the closest point to your project and copy and paste the EPW link into your model. So that's all we're doing here to get the weather file. This is really important, the north. This is probably the thing that I see students forgetting to do most often, is that they'll have, so a lot of times, the project for this class is oftentimes in New York, and so when people model on a grid, you just tend to, model it north, north along, or not north, you tend to just model the grid so that it lines up with the XY axis as opposed to true north, which makes sense, but you just need to make sure that you account for that. So I know in this case, if we were doing this in New York, there's a roughly, I believe it's like a 29-degree rotation to align with true north. So, and if you wanted to like visualize this and confirm, you can bring in like the sunlight, the solar visualization tool from Ladybug and whatnot, but I'm not going to do that here. But just remember, this is, I think, again, this is one of the things that I think people forget to do the most that makes like a huge impact on your analysis. You can set up every single wall thickness and shade and every little bit right, and then if your entire model is 30 degrees off, then your analysis is pretty much worthless. So make sure to rotate your models. And then the next step is going to be to run the recipe. So we'll plug our recipe into here, and then we can put a Boolean toggle. And if you wanted to like see the report, you can throw a panel at the end here and plug that into here. I think you can kind of read. It says, but I think by default it's turned off because it slows things down a little bit. But in this case, our model's pretty light, so it's not a big deal. And I guess before I run it, I'm just going to kind of plug in the last couple of components that are going to be our visualization components. So if we come back to here, the daylight metrics this is going to kind of give us the values or parse out the values that we need. So these will be our results. And then there's going to be like a heat map that we'll use to visualize the results. So the output that we're going to plug into that is the daylight autonomy, so the percentage of time that each sensor receives equal or more than the threshold. So that makes this threshold pretty important. So this is the daylight autonomy in lux, so by default it's set to 300. So depending on the building program, you want to really make sure that you set this to something that makes sense for you. So you can always kind of just like Google the lux levels for different types of programs. So that's what I did here. So you can find something like this. Doesn't have to be this one exactly, but for typical office work, it's saying like recommended is 500 lux. Now if you're depending on a lot of factors as far as like the type of work, if it's everyone is working on a computer, maybe it doesn't need to be that high. So you just interpret whatever you're finding online. Just think about it. Before just accepting anything. So our threshold might be, maybe we'll do something a little bit lower than 500, but maybe something a little bit higher than 300. So let's just say like 400 will be our kind of threshold. And that's going to be, again, the number of times that the sensor receives equal or more than the threshold. So let's say if our ideal kind of point was like 500 lux, we would probably want our threshold to be lower than that. So with that set up, and then the last thing is we want to connect our mesh. So the mesh is going to come from the grid that we set up here. And I think we should be ready to run it now. So I'll zoom in here and we can run it. And this should take like a minute or two. While it's processing, I also wanted to point out, so similar to where I was finding, so on GitHub, on the Ladybug GitHub page where I found the Honeybee schema, You can also find, they have like all the uh, different schemas, and you can also find the sample files. So if you come to the Honeybee Grasshopper Radiance, you can find some sample files, which is kind of what I had done to help get me started on this just before putting this video together. And so there's some nice sample files, and so the annual daylight sample file is very similar to what I just went through. I think I had it up here, so it kind of runs through and has everything kind of nicely grouped. So you can see that this is doing a very similar kind of like geometry prep, setting up the model and the grids, running the recipe, and then visualizing the results. So this is our results. So we can come in here and take a look, and this looks like it looks pretty reasonable considering where our windows are and where the context is and whatnot. So we can begin to now use this data to inform, if we were laying out offices in here, or laying out lighting or whatnot. So this is just again, this is a very introductory kind of setup to help get people started on using the Honeybee tools and maybe running a basic daylighting analysis. So hope you found this helpful, and thanks.